Now we are going to discuss different parts of atmosphere. But before starting out the structure of atmosphere exactly, I had to take you to again certain points in the physics. As we discussed earlier that radiations are there, I want to just give you here certain ideas that suppose I am giving you here single axis graph of this radiation. Try to recollect, in earlier lectures we discussed about this, that highest energy in our known thing, that is gamma radiation, then it is X radiation, then it is vacuum ultraviolet, then it is ultraviolet, then it is visible. Now this is VIBGYOR. So only this much portion of spectrum that is visible in nature. Try to recollect, we have discussed these all. Then it is infrared, then it is far infrared, then it is microwave, and then it is radio wave. So energically or wavelength wise, this graph is acting in reverse way. So this is wavelength wise and this is energy wise. So gamma rays are having shortest wavelength and radio waves are having longest wavelength. Gamma rays are having highest energy, radio waves are having minimum energy. Why we require this type of chart here? The reason is that when we are talking of atmosphere, certain facts are there and I have to explain that facts on basis of this radiation concept. Say we are there on surface of earth and we are able to observe visible various visible object from earth surface. For example, astral objects. For example, I can observe sun, I can observe moon, I can observe different stars. What is the meaning of that? I can observe means you also are able to observe. What is the meaning of that? That light coming from these objects, they are coming towards us and therefore we are able to observe them. Maybe possible distorted one, not straight one, but still light is penetrating through the entire atmosphere and then we can able to observe that. Suppose we are provided with ultraviolet vision, then in ultraviolet, or now we have camera, that with ultraviolet camera we are not able to observe certain ultraviolet radiations. No doubt these ultraviolet radiations are emitted by these distant objects, but because there is section that is called as vacuum ultraviolet, they are having existence in vacuum. The moment they enter in the atmosphere, they get absorbed by atmosphere. Even gamma rays, say sun, moon and variety of other bodies in the space, they are very good source of gamma rays. For example, moon is much more brighter than sun in case of gamma rays emission, because sun is continuously emitting out charged particles. As we discussed in earlier part, that in case of earth there is aurora borealis or aurora australis, that is southern light and northern light. Then these charged particles get discharged in earth's atmosphere only. But in case of moon, as atmosphere is very rare, these particles get hit means they get attacked, collide over surface of moon with very high speed, and then moon surface emits gamma rays because of that. So suppose I am having camera that will record gamma radiation photograph, then obviously moon will appear much more brighter than sun in that gamma ray part. So gamma rays are emitted by these astral bodies, but we are not able to locate out it from surface of earth because gamma rays are having hardly range of 10 to 12 centimeters in atmosphere. So they get also absorbed in atmosphere. So whatever the light that is coming out from atmosphere, coming out from these bodies, they are passing through atmosphere, that only we can observe, and fortunately that is visible light. That means visible light is not absorbed by atmosphere. See what happens, particular substance absorbs some light, then obvious thing is that that energy of light is absorbed by that surface. Now usually when we are having a surface, suppose I am drawing here, this is a surface, whereas radiation is incident on it. So this is incident radiation. What will happen to this radiation? Totally, I have to say 3 probabilities are there. Number 1, part of that light is reflected. It is not that all radiations are reflected back. Only part of light is reflected. Part of light may be change their path and transmitted. So this is called as transmitted. And part of light is absorbed here. So suppose this is 100, then some X portion is reflected, Y portion is absorbed, and Z portion is transmitted. Do you believe? It's difficult to believe, but certain exercises we can carry out. Say for example, if you observe aluminium foil that we are using as wrapper usually. So that aluminium foil, we think that it is opaque. Opaque means what? Either light is reflected back or it is absorbed. This component should be 0. That means it will not transmit any light. But just check out. You can check out first with ordinary tube light. What I am telling, we have to keep that aluminium foil in front of you and try to observe tube light. Ordinary tube light. If you are able to observe that tube light, then don't carry out experiment further. Because as you are observing that tube light through aluminium foil, that means light coming from that tube light that is transmitted out through that foil. So as it is appear to be opaque, but it is not opaque. It is transmitting out light. If you are not able to observe tube light from that aluminium foil, then take that aluminium foil and observe sun at afternoon from that coil. You can able to observe sun through aluminium foil. But keep in mind that aluminium foil should not, we have to test like that tube light should not be visible from aluminium foil. Then only take that aluminium foil to observe sun, otherwise don't use that. Again, don't stare too much time towards sun. Just we have to take a look and remove. Now here we'll get that you are able to observe sun from aluminium foil. That means part of light is transmitted. No doubt, suppose somebody is observing from different angle, he may observe shiny surface of aluminium. That means what? Part of light is reflected. And if you check out after some time, the foil is heated. That means part of light is absorbed also. Even hold your hand in front of a torch. You will observe that it is enlightened one. That means light is transmitted, light is absorbed, and you can able to observe hand. Now you are able to observe hand. That means part of light is reflected. So these 3 incidents we have to keep in mind, that part of light is reflected, part is absorbed, and part is transmitted. You may observe this from auto rickshaws glass also. That windshield is there for auto rickshaw. That is flat actually. From that also you may observe many times that reflection of sunlight. Yes, like flash comes out, that reflection is there. That's why on glass surface also part of light is reflected. Part of light is transmitted. That's why that auto rickshaw driver is able to observe you through the glass. And if you keep it for longer time in sunlight, then obviously that glass becomes hot. That means part of light is absorbed by that glass. So this way, first part is that when incident radiations are there, 3 cases are possible. Now in case of visible light, little bit visible light is absorbed by atmosphere. Majority of visible light is transmitted, and therefore we are able to observe the stars, moons, etc. from surface of Earth. So atmosphere is not absorbing visible light. What is the converse of that? That atmosphere is not heated because of this visible light. Clear the concept? Because heat is generated only when light is absorbed. So here, as absorption, no doubt, I am not saying 100% light is transmitted, part is absorbed, but that Y component here in case of atmosphere is very, very, very less, and therefore heating is not observed because of this type of visible light absorbed by surface, visible light absorbed by atmosphere. Now that visible light is coming to surface of earth. Depending upon the color of surface of earth, certain part is reflected. Suppose it is part of Himalaya mountain range, particularly greater Himalaya, which is having snow covered area, then the observed color is white. As color is white, maximum light is reflected back and very less light is absorbed. To some extent it is transmitted also, but maximum light is reflected back. So there is no question of heating out surface, particularly if color of surface is in white range. In case of Maharashtra, maximum soil, I am not saying all soil, but maximum soil is black soil, that we are calling as cotton soil or regur. Some people are pronouncing as regur. So regur or regur soil, which is having titaniferous magnetite. Because of that titaniferous magnetite, that regur soil is having black color. Obvious thing is that as it is having black color, the incident radiation is absorbed to greater extent and reflected back to minimum extent. So that radiation is absorbed, soil get heated. Now you are aware that any hot body, what is hot body? Again I have to remind you that if temperature is greater than minus 273.15 degrees Celsius, remove this 15 degrees Celsius, consider that as only for general purpose minus 273 degrees Celsius, we are calling this as 0 Kelvin, that is absolute zero. If body is having temperature greater than absolute zero, then that is called as hot body. So ice is very, very hot body, whereas our body, which is having temperature 37 degrees Celsius, is also very hot body. All these hot bodies, they are emitting out certain radiations, particularly that is in range of infrared radiations. And that's why, if you are aware that there are night vision cameras, particularly infrared cameras, or we are calling more as thermal camera. So all these things emitting out infrared radiation. So whatever the surface that is absorbing light, that is get heated and it reflects back in form of infrared, not reflect back, radiate back in form of infrared light. Now this infrared light is called as low energy light or longer radiation. So longer means what? Their wavelength is long. So they are called as long radiations. To the surprise, atmosphere is able to absorb these long radiations. Not short. Short means visible, till visible. So here to here we are calling short radiation. On here they are called as long radiations. So these long radiations emitted by surface of earth, they are absorbed by atmosphere. As a result, we are getting rising temperature of atmosphere. Getting idea? That's why if you are at lower altitude, say for example you are at sea level, then temperature observed is maximum, because as soon as these long radiations are entering in atmosphere, they get absorbed by atmosphere and atmosphere get heated. So atmosphere is not heated because of incident radiation. Atmosphere is heated because of whatever radiation is absorbed and then it is radiated back from surface of earth. Because of this radiated back radiation, they are in form of infrared. Because of that, atmosphere get heated. As a result, at lower altitude, that means height from sea level, we are having higher the temperature. As you are moving at high altitude, temperature decreases. Usually, for every 160 meter altitude, temperature decreases by 1 degree Celsius. I'm again reminding you, usually, this is not hard and fast rule, but general rule is that at 160 meter height, temperature decreases by 1 degree Celsius. This is called as lapse rate. So what is lapse rate here? That is, temperature decreases for 160 meter altitude by 1 degree Celsius. Let us check out example. I am there at suppose Kasara railway station, which is having altitude around say 50 meter, suppose. Whereas there is highest peak in Maharashtra just nearby Kasara station, that is Kalsubai, which is having altitude at 1646 meter, consider 50 meter. So what is difference between height? That Kasara is at 50 meter and Kalsubai is at 1600 meter. So what is difference, level difference? That is of 1600 meter. You are aware, for every 160 meter, temperature decreases by 1 degree Celsius. For 1600 meter, what is the decrease? So what I have to do? I have to do this by this, multiply by this. So simple, 1 by 160 multiply by 1600. You may cancel out 1 0 this, so remainder 10. So temperature will decrease by 10 degrees Celsius. So suppose I am at Kasara, temperature is 30 degrees Celsius. Then what is the expected temperature at Kalsubai? That is 30 minus 10, that is 20 degrees Celsius. So this way we can generally calculate temperature difference. Now, is it possible that on equator snowfall is there? Again go by same equation, that equator is having temperature around 30 degrees Celsius suppose. I have to decrease temperature by 30 degrees Celsius. For that purpose, I have to take calculation as 30 into 160 meter. So 1020, 16 3s are 48. So I had to go 4800 meter high from equator. Then there is temperature which is 0. If I am going to still higher altitude, then obviously temperature will be less than 0 and snowfall is possible depending upon climatic condition. Such place is there in Africa, that is that is there on equator, named as Kilimanjaro, which is having altitude greater than 5000 meter, and then we can observe extreme cold climate on equator, particularly at Kilimanjaro, a peak in Africa. So this way we are calling this as lapse rate. Temperature decreases for higher altitude, but this is not the case that always the same, because above certain part of atmosphere, that higher altitude, the composition of atmosphere change out, and then there is presence of ozone layer. Ozone is capable of absorbing certain ultraviolet radiations, and because of that the ultraviolet, that is high energy radiations, are absorbed, temperature rises again. So it is not that always you are traveling towards higher altitude you will get lower the temperature. No, above certain part you will get that there is rise in temperature, and then reason is that because ozone layer is present over there, and as ozone layer is present over there, it absorbs ultraviolet radiations. Not all, certain ultraviolet radiations are absorbed by that ozone layer, and therefore we are having again rise in temperature. So there must be some part, we are calling that a zone. So this way we are getting again thing that above certain temperature, above certain height or altitude, again temperature start decreasing out because ozone layer depletes out there, and then there is again fall in temperature. So like that different zones are there. we have to study these zones in detail. So particularly we are now discussing about structure of atmosphere that we have to discuss in detail right now.